Electronics. They're the heart and soul that drive modern-day wonders like your phone, your tablets, and your computers. But what's inside these devices that bring them to life? The answer? Semiconductors. So what is a semiconductor? Let's break it down into two separate words to begin with. You have the word semi, and you have the word conductor. So, let's focus on the first word, semi. Semi means, for this example, semi-okay at something. So, if I were to tell you I'm semi-okay at football, then I'm telling you that I'm okay at it, but I'm not the best. Now let's look at the second word, conductor. Think of a train conductor. When you're on a train, they ask for your ticket, they ask if you want something to eat, and for the most part, they're telling you where to go and what to do and how to be safe on the train. In the context of electronics, a conductor, in this case, would be a piece of copper. This piece of copper is telling the electricity where to flow, acting as a conductor. Putting these two words together then, we get semiconductor. In the context of electronics now, we have something which is semi-okay at conducting electricity. But why would you want something that's only semi-okay at conducting electricity? Surely you would want something that is the best at it, or the most effective, like copper, or something which isn't good at it at all, like an insulator in this case, which doesn't conduct, like rubber. But that's the exact thing which makes semiconductors vital to drive our modern day industries and our phones. Take a light switch, for example. When you press the button, it connects the two pieces of metal together. This allows electricity to flow through the circuit and then turns the lights on. But what if we didn't need to have a physical press of a switch to control the electricity? That's where semiconductors and our new best friend, the transistor, come in. The transistor in this case acts like a switch, but instead of pressing it on and off and creating a gap and closing it, we simply use electricity. As you can see in this diagram, there's three legs: the base, the emitter, and the collector. Now for this case, we're only going to be looking at the base. Using the base, we can control how and when the transistor turns on by supplying electricity to it. So if we supply electricity to it now, on the base, it turns on. How does it do this? Well, when you supply electricity to it, you change how the semiconductor reacts. So instead of it goes from acting like an insulator to acting like a conductor because of smart chemistry. Now, what are these semiconductors made out of? Typically, the most common thing they're made out of is silicon, like the sand off the beach. Now, what they do is they take the sand and they make it as clean as possible, get rid of anything that isn't silicon. Then, once they have this, they melt it and they twist it into an ingot. This ingot is then sliced very, very thin, with these very, very thin layers being experimented on, having different elements and something called doping, where you change how it reacts. This doping then is done very specifically to where, again, you apply electricity to the base, it turns on.